Here we are at Station 1, which is used for Experiment 1. For our materials, we have the Bunsen burner, standard Bunsen burner setup, and we have cupric sulfate. Now, nowadays we don't really use cupric, we would call this copper 2 sulfate pentahydrate. So, one thing to note right off the bat about this, I haven't really taught you guys what this dot means. This dot does not mean a plus sign like you see on the other side. This dot really indicates that all of this is going to be one compound. So this whole thing on the left side, from the copper, the sulfate, and the 5 waters, are considered one large compound. Then we're going to apply heat and turn it into copper 2 sulfate and 5 waters. Now they're 2 separate compounds. So our starting material, which you saw came from this stock bottle, is right here. This is our starting chemical, the only chemical we're going to need in this. So remember to make your observations, see what it looks like, mention its color, mention its state of matter. Are these little rocks? Are they little crystals? Is it a powder? Mention anything you can when you observe it. I know it's a bit more difficult since it's through a video, but we're doing the best we can. So the whole experiment, if you read through the procedure, involves putting this compound on top of the Bunsen burner, which we're going to do now. Let me get my prongs. So we're going to take the compound here, we're going to set it up, and just let it set. And we're going to let it go for just a couple minutes. So the reaction's been going for about a minute now, and already you should be able to hear that something's taking place. And also, if you look over here along this edge, you should notice a small color change. If I were to scrape away the top layer here, you notice it's starting to stick together. And it's not quite as powdery as it was before. This reaction will continue to take place over the course of about 5 to 10 minutes. So here at the bottom you can kind of see the whitish layer where it's losing its color. Here is where you would mention any observations of noticing what's going on during the reaction. And there's one main thing that you should be able to see, and that's mentioning what's going on with the color. Now, after about 5 or 10 minutes, let's turn this off. We're not going to sit here and watch this whole thing. I already have one that I had go through. It will eventually lose all of its color. And if you look at it and you play with it, you notice it's still powdery. But what's it look like now? Now that the reaction is gone, we say this is our after. Everything's probably about 99% finished. What observations can you make? Did its state of matter change? Did the shape that it holds changes? Is it still the same type of physical build that it was before, such as is it crystals, is it little powder, is it clumps, etc. And the final thing you need to ask is, what type of reaction is this? If we go back, we look over here, notice we started with one reactant, and we end up with 2 simpler products. Make sure to mention in your homework what type of reaction you think it is, as well as any observations you made before, during, and after the reaction taking place. Here we are at Station 2. Station 2 involves reacting magnesium metal with hydrochloric acid to form the magnesium chloride salt and hydrogen gas. Our starting compounds come from these stock bottles. So we have a hydrochloric acid solution here, and we have magnesium metal turnings. Now, so you guys can get a better idea of what these look like, we're gonna come over here. This is our hydrochloric acid. I have it in a little test tube here. But what state of matter is it in? Does it have a color? Can you notice anything else about it? Down here, you'll notice we have our magnesium metal turnings. What do they look like? What can you notice about these? What color are they? Now, in this case, we have two starting chemicals. So instead of putting it on a fire, what we're going to do is we're going to take a little bit of our HCl, the hydrochloric acid. We're going to come over here and we're going to apply it directly to our magnesium metal. Now, when we do that, you should obviously note what's happening here. So what's happening during the reaction? You should be able to both see and hear something happening. You see a bunch of bubbles and you see some vapor coming off, just a little bit. What could this vapor be? Take a second to look at your chemical equation. Not the one that I had listed on the station sign, but the one provided in your homework. Look at the elemental states or the states of matter of your products. Which one would probably likely come off as bubbles? Now, you can back up if you need to, but you remember what color these metal turnings were. After about 5 minutes, the bubbling, all the acid reacts away, and you end up with something that looks a bit more like this. So you notice the bubbling has stopped. There's no more hissing sounds. And the colors change. Well, it looks like there's a little bit of bubbling still, but for the most part, it stopped. It's not quite as volatile as it was before. And what's happened to the color here? Is the liquid still the same color? Do we still have two individual compounds? You should be able to see a little bit of the color difference there. Make any observations regarding this as you're after. So here we are at station 3. You'll notice it has a slightly more complex reaction than anything we've seen thus far. Here you see we have sodium carbonate, which is reacting with calcium chloride dihydrate. It forms calcium carbonate, 2 waters, and 2 sodium chlorides, which is table salt. So what's happening is the calcium separates from the chlorines and kicks the sodiums off to join with the carbonate. So we have calcium carbonate. The waters go off by themselves once the calcium chloride has been broken apart. And then all that's left is the sodium and the chlorines, and they decide to pair up over here. Now, looking at our starting chemicals, this is our sodium carbonate. Some say it has a slight yellowish color. That's your opinion. This is the before part of the reaction, so describe it as best as you can. Your other chemical is this one. This is your calcium chloride dihydrate. Now, make sure, as always, to describe everything you can observe about these chemicals. So that's the sodium carbonate and the calcium chloride. Make sure to mention their states of matter, any colors, anything that kind of stands out about them. Now here in this test tube, I have a little bit of the sodium carbonate. And what's going to happen is I'm going to combine it with a beaker or a little pipette filled with the calcium chloride dihydrate. Now logic tells us that if we take 2 clear liquids and combine them, we should end up with another clear liquid. But when I do this, hopefully you'll be able to see it. you'll notice it's not quite as clear as we expected it to end up being. Now what's happened here is we still have a little bit of liquid, and that liquid is salt water, because remember we had 2 table salts and 2 waters that separated as part of our products. And all the white stuff here is a precipitant, and this precipitant happens to be calcium carbonate. Now, calcium carbonate is something that a lot of you have messed with before. It's actually sidewalk chalk. So if you were to take a piece of sidewalk chalk, grind it up into a powder, and then mix it with if you were to mix it with salt water, this is what you would get. Except instead of buying a piece of calcium carbonate, or buying a piece of sidewalk chalk, we just made it ourselves in a chemical reaction. Now, this is your during, is this state right here. However, this one takes several days to settle. And when it does settle, you end up with this. So here, notice, we still have the salt water at the top, but at the very bottom, there's a little pile of a powder. Oh, I guess we'll do it from the beneath. That powder is the sidewalk chalk, the calcium carbonate, that settled over about a 4-day period. And that was just a tiny little bit. That big test tube that we just did would have taken a week or more to settle out. But this would be your after observation. Again, describe any chemicals you can see. You should be able to see 2 distinct chemicals here, the stuff at the bottom and the liquid on top. Describe everything you can about them, including color and their states of matter. Also, predict what type of reaction you believe this to be. Here we are at station 4, and here's our chemical equation. So here we have 2 ethyl alcohols react with 7 oxygen gas molecules to form 4 carbon dioxide and 6 H2O, 6 waters. Now, our starting chemicals are the air, oxygen gas, which is just a gas present in the air, but that is a starting chemical, so describe it as best you can. What state of matter is it? Can you see it? Etc. But then our other chemical is ethyl alcohol, or ethanol. And it's this little beaker right here. So you notice, what state of matter is it? Any observations you can make. We have about 10 mils of it here. Or sorry, about 13 milliliters. Now, we're gonna take our little pipette here. We're gonna grab some of this, and we're gonna put it in this little watch glass. We're only gonna put a little bit. Because we want this to go kinda quickly. So, we're gonna react it by setting it on fire. So this is the during part of your observation and your experiment. What's happening? Describe what's happening. Is the amount of chemical remaining constant? Is the size of the flame remaining constant? Stuff like that. And eventually, our flame goes out. Now, looking here, you'll notice there's nothing left in the watch glass. I would touch it to kind of tilt it around, but it's going to be hot because it was just on fire. So trust me, it's not a trick. There's nothing left in the watch glass. So where did our chemical go? Now, I didn't put states of matter on these chemical equations because I wanted you guys to tell me what they were as part of your observations. But what happened to the states of matter, to the chemicals that were in here? What happened to the ethanol? What happened to the oxygen gas? Describe it as best you can and predict what type of reaction you believe this was. Now here we are at the final station, station 5. In this reaction, we have 2 magnesium atoms react with oxygen gas in the air to form 2 magnesium oxide. Now, what you may not notice, or may not know because I didn't include it, is that this reaction has to be heated. So this is one of the few instances where you would use your little triangle symbol, such as that. Now, our starting chemical is just going to be magnesium metal, or at least the one that you can physically see. This is just a piece of magnesium ribbon, which just means it's basically cut almost like a wire, almost like a little ribbon. And it's just pure magnesium, safe to touch, safe to handle. Your other starting chemical is oxygen gas. So describe the oxygen gas as best you can. You probably won't really be able to describe it. Now, I'm going to set the camera down for just a second so we can grab our magnesium ribbon. So I bent it a little bit so you can easily see it. Now, this is our Bunsen burner. What's going to happen so you'll notice this is our during. What's happening should be very obvious. And we started with that metal, but now our afters that we're left with this ash-like material. Describe it as best you can, color, state of matter, etc., and predict what type of reaction you think this is. One thing to note is notice, what did we start with? What did we end with? A lot of people would call this a combustion reaction. However, in class, we've been talking about combustions of hydrocarbons, not just combustion in general. If you believe this is combustion of a hydrocarbon, remember to look at the products of what a combustion of a hydrocarbon happened to be, and match it to this and see if it matches.